Let's pick up where we left off in the last video. We were trying to identify what big R was and what little r was. Big R being the outer radius, little r being that inner radius, by taking the same region in the plane we've been working with, but now spinning it around a line that is not the y-axis or the x-axis. It is a vertical line, so we know our thicknesses are going to be with respect to y. That's already established. Let's draw some representational big R's. There's a big R, there's a big R. We can clearly see that big R is being controlled by our line y equals 2x. Big R is just sailing right through the parabola y equals x squared. Y equals x squared is not in control of what's going on with big R. This function is. Now again, we're doing things with respect to y, so instead of y equals 2x, we're actually talking about the line in the plane x equals 1/2 y. Right ear on right shoulder. I want to show you something. If we say, for example, therefore big R has to be 1/2 y, what we're telling, right ear on right shoulder, what we're telling our mathematics and our integral when we pop it in there is that we're talking about the region in the plane trapped in between the line x equals 1/2 y and the y-axis. This is actually 1/2 y, this distance right here. And we can see that's not what we're after at all. This is 1/2 y. This is 1/2 y. It's the region with the upper bound of the line, x equal 1/2 y, and the y-axis. What we're after is what's left between that line and the distance here. This distance is constant all the way up. The distance between the line about which we're spinning and the vertical axis here all the way up and down is a distance of 2. So we're going to use that, and we're going to recognize that for us, our big R is not just 1/2 y. For us, big R is the distance 2, taking that line according to y out of it. So if we have this distance 2, and we subtract out of there this distance from the y-axis to the line x equal 1/2 y, here's what's left over. And that clearly is big R. So you can see finding our radius, our big R and our little r, when we're spinning around a line that's not an axis, can be a little tricky. So now let's try to find little r, and let's draw some representations of it. There's a little r, there's a little r, there's a little r. Clearly the function in charge of what's happening with little r now is the parabola y equals x squared, or again, according to the y-axis, x equals the square roots of y. Now again, right ear on right shoulder. If we call little r the square roots of y, then what we just identified is the region in the plane trapped in between the y-axis and the root function right there. Here is the square roots of y everywhere. And clearly we can see that's not what we're after. This is what we're after right here. So just like we did with big R, this distance is still a constant 2. Little r is going to be 2, the whole distance, taking this region out, or subtracting our root function. So finding big R and little r when we're spinning around a non-axis line, either vertical like this one, or you'll see some homework examples that we're spinning around non-axis horizontal lines, finding big R and little r gets a little more tricky. But now that we've done it, let's go ahead and find our volume. So volume equals pi times the integral. We're using the same region in the plane, so we know our limits of integration have not changed. So big R is the quantity 2 minus 1/2 y, and we square it. And little r is the quantity 2 minus the square roots of y, and we square it. So there's our integrand, and we are going to integrate with respect to y because our thicknesses on our washers are in terms of y. Our thicknesses run along the y-axis, so that's dy. Okay, so let's just do, now we're just down to the calculus of things. We'll clean things up here. There's some algebra that's going to go on there. We need to, and I'll write this out for students that might need to see it, just especially the first time there. So I'm going to FOIL this out. 2 times 2 is 4. I have a minus 2 times 1/2 y, which leaves me a negative y. I have another minus 2 times 1/2 y, which leaves me another negative y. So I have minus 2 y's. And then I have plus 1/4 y squared. And I'm going to subtract from that. I have to FOIL this out as well. For those of you that want to see the FOIL a little more clearly, some of us have better algebra practices than others. Please don't forget to put your parentheses here. This negative is going to distribute through all 3 terms you're fixing to find. So 2 times 2 is 4. I have a negative 2 square roots of y. I have another negative 2 square roots of y. So I have minus 4 square roots of y. And then negative square roots of y, positive square roots of y is a positive square roots of y squared, or just y. So again, we could take another step, clean it up with algebra. We have 4 minus 4. Those are going to disappear. Here's a negative 2y. Here's a minus another negative y once I distribute that negative. So my first term here is negative 3y. This is my only y squared term, so I'm just going to copy it down. And this is my only square roots term, but a negative and a negative makes a positive. And since I know I'm going to use the power rule for integrals, then I'm going to write it as a power instead of a root. So now I just need to find the antiderivative function. Negative 3/2 y squared plus 1/4 times 1/3 is 1/12 y cubed plus 4, and this is going to be 2/3 y to the 3/2. So 4 times 2/3 is 8/3 y to the 3/2, and I'm going to integrate that from 0 to 4. Now I'll just take one more step and plug those values in, but I'm not going to go ahead and clean it up. 4 really is the only value that I need to plug in. Please be meticulous at this point. Don't drop your guard. Please make sure that you're writing everything that you need to write and being meticulous about it. And that's minus 0. The pi needs to distribute all the way through. And there we are. There is the exact volume of the 3-dimensional solid, which is going to look like this, the 3-dimensional solid that comes from taking this region in the plane and spinning it about the vertical line x = 2. So that'll finish up this third and final video. Come to class next time and we'll work some washer method homework problems.